Question 3, we have a circle theorems question here where we are given that TV is a tangent to the circle, touching the circle at point P. We have that SR equals RQ, which we have written there, but we also have that implied by these lines on the lengths. We've been given angle QPV is 41 here, been given angle SQP is 57 here, and the end game here is to find the size of angle SQR, which on our diagram is this angle here. So that's the end game. So as is the case with most circle theorems questions, you're going to try and figure out the size of any of the angles I'm about to highlight here. So there's this one, there's this one, there's this one, there's this one, there's this one. Basically any other angle that's not been mentioned. Even all of this might have been useful, or all of this might be useful. So if you're unsure about this, start trying to figure out as many of these as possible. Some involve circle theorems itself, others involve general angle rules that you would be expected to know before. So one of the things in this question, we must give reasons for each stage of workings. Now, to save on the length of this video, I'm going to say it out loud what the reasons are, and I'll slow down what I say so that you can hear it clearly. And of course, we need to show all the workings mathematically to get them. So the first circle theorem that I see is the alternate segment theorem. So that is the angle between a tangent and a chord is equal to the angle in the alternate segment. You can just write alternate segment theorem, and that will get you the marks for it as far as the reason goes. So we get 41 degrees from that. What I can then do next is say that angles in a triangle add up to 180. So you'd have to write angles in a triangle add up to 180 in conjunction with showing that when you take 41 and 57 away from 180, you're going to get 62. If I've done that right in my head. Nope, that's not right. 62 is not right. It should be 82. We have 82 degrees there. It's worth noting that you could have done this another way as well. You could say the alternate segment theorem is why that 57 degrees is the same as this 57, and then instead of angles in a triangle add up to 180, you could say angles in a straight line add up to 180. So you've got two different options there to get that green 82. Once you've got that green 82, we are going to use opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180. So if we take this 82 away from 180, we get 98 degrees, which is the size of the angle there. We then have the two angles here. The base angles in an isosceles triangle are equal, and then we would also have to mention that angles in a triangle add up to 180 if we hadn't already said it from before. So if I did what you see here that I've done, that find the purple angle 41 here first, and then find the green one, you've already said angles in a triangle add up to 180, so we don't need to say it again. However, if we had found this 57 to give us this one, and then did angles in a straight line add up to 180, I would have to say for this triangle here, angles in a triangle add up to 180. So you've just got to make sure you state the rule every time you use it. The only time you don't have to write it again is if you've already said it. So in any case, I take away 98 from 180, and I get 82, which is both of these angles combined. And then by using base angles in an isosceles triangle are equal, that's what allows me to say that half of this 82 will be the size of our x. So x is 41. Done.